Okay students, theorem number 10.7. Theorem 10.7 is converse of theorem 10.6. Done? So here, chords equidistant from the center of circle are equal in length. In theorem 10.6, we have proved that two equal chords of a circle, length of chords are equal, that was given, and we have proved that equal chords of a circle are at equidistance from the center. Now here the statement is converse of that theorem. What is the converse? Given is not that you have to prove. To prove, that is given. So now chords are equidistant from the center, and then you have to prove if the distance of two chords from the center are equal, then two chords are equal in length. That means two chords are congruent chords. If the distance of chord from the center is equal, then two chords are equal. So diagram, chords distance. Chords are equidistant from the center of circle. So two chords are there. For example, AB and CD. Two chords are given, and here we are given that these two chords AB and CD are equidistant from the center of circle. So distance of this chord from the center, for that we have to do perpendicular. This is circle with center O. Circle with center O. It's a perpendicular, and distance of this chord CD from center O is ON. This is OM and this is ON. So distance of this distance of these two chords from the center are equal. So these two lengths are equal, given. This is given. We have to prove the length of these two chords are equal. Done? Consider radius of the circle OB and OD. And also we have proved that perpendicular drawn from center to chord bisect the chord. So here M is the midpoint of this AB. So length of this AM and BM equal, and length of this CN and DN is equal, because ON is the perpendicular drawn from center to chord. So it will bisect the chord. Done? So now given chords equidistant from the circle. So in circle with center O, in circle with center O, distance of chord from the center are equal. So here OM equal to ON is given. Then what is OM? OM is the distance of chord from the center. That means OM is the perpendicular drawn from the center to chord, and OM is the distance of chord CD from O. So OM is the perpendicular from the center O. So here we can write OM is perpendicular to AB and ON is perpendicular to CD. And if you want to find the distance of any chord from the center, then we have to draw perpendicular from center to that chord. And if we are drawing perpendicular from center to chord, that perpendicular will bisect our chord. That is our theorem. So here M is the midpoint of AB. So therefore we can write AM equal to BM, and here ON is perpendicular to CD. So we can write a CN equal to DN. So many things are given. For this condition, we have to prove. What we have to prove? Chords are congruent. Chords are equal in length. So AB and CD both are equal. The length of these two chords are equal if their distance from center of circle are equal. Clear students? This is our given and to prove. So let's start with our proof. Students, we have to consider these two triangles OMB and OND. So in triangle OMB in triangle OMB and triangle OND. Consider these two triangles. We have to prove these two triangles are congruent triangle. Directly दिख रहे हैं. So here given OM equal to ON, OM equal to ON. This is given in the sense equidistance. You know, this is given. Distance of this chord from the center are equal. So distance of chord AB from center O is OM, and distance of chord CD from center O is ON. So these two distances are equal. OM equal to ON. This is given, equidistance. Then OM angle OMB equal to angle OND. OMB angle OMB equal to angle OND. Right angles. Because to find the distance of this chord from the center, we have to draw perpendicular, and if we draw perpendicular from center to chord, it will be at a 90 degree. Done. So OM is perpendicular to AB and ON is perpendicular to CD, and that's why this angle OMB and angle OND are 90 degree. We are using RHS criteria. Right angle hypotenuse OB equal to OD. OB equal to OD. These are the radii of the circle. Radii of circle. So right angle hypotenuse and sides are equal. So by RHS criteria we can say that triangle OMB is congruent to triangle OND by RHS rule. By RHS rule, these two triangles are congruent triangle, and that's why their corresponding parts are equal. So here we can say that this MB equal to ND. The length of the sides MB equal to ND by CPCT. Corresponding parts of congruent triangles are equal. So these two triangles are congruent triangle. This MB will be equal to ND, and therefore that twice of MB will be equal to twice of ND. So twice of MB is nothing but the AM plus BM. So it's a AB, and twice of ND is nothing but the CD. So AB is equal to CD. So these are the length of two chords AB and CD. So these two chords having the equal length, so two chords are congruent chords. Hence it proved. Clear? So chords equidistance from the center of circle are congruent. Clear, students? Pause the video and note it down.